Okay, so we're talking about ionic compound nomenclature, which is the naming system. And the naming system is that we just say the name of the metal. Ionic compounds are pretty easy for naming. We say the name of the metal, we say the name of the non-metal, and at the end we put IDE. So an example is NaCl is sodium chloride.
Example.
Yeah, sodium chloride is the best example ever because it helps us remember ionic compound properties. It helps us remember the nomenclature. It is wonderful. It's a good one to think about. So you could think about it like chloride, ide at the ends. You have your metal and your non-metal, and then together you have so like iron and oxygen make iron oxide. Anyway, do you guys remember this from physical science?
No, but
it's pretty easy. Well, this is like the basic thing that you learn in physical science that we're going to review, and then we're going to add on the things you didn't do in physical science.
do y'all not?
Are people being crazy?
Yeah. It's probably Mr. Ellis' class. They had
They're
this
leaving.
big, like, and dizzy bat thing where we had to, like, run across how people, like, sling.
Okay, so something that helps us sometimes figuring out, not necessarily the naming for these, but when we get the other way, when we're writing the compound structure and not the name, is drawing a Lewis dot structure for the ionic compounds. Do you guys remember our Lewis dot structures?
Yeah.
What do we do for those?
You put I think like the valence electrons, right?
Yeah, we put the valence electrons. And we can do it showing our ionic compounds as well. So we look at, for this first one, CsCl. So Cs is what?
Cesium.
Cesium. So if we look at cesium, cesium has how many valence electrons? It has 1. And chlorine has how many valence electrons?
9.
Nope. Try it again.
7.
7. So 1, 2, 3, 4, 5, 6, 7. So what's going to happen when these bond? They're going to transfer. So this one little guy is going to come over here. And actually, when you write it, chlorine will have all the electrons, and cesium will have none of the electrons. So chlorine will be what charge?
Negative.
Will be -1 because it gained an electron. Cesium will be what charge?
Positive.
+1. So this is just using our electron dot structures to show what's happening in the bond. So one of the electrons goes to the other one, and because of that, the positive charge of this atom and the negative charge of this atom, what do those opposite charges want to do?
Become
Opposite charges do what?
attract.
Attract. So they attract, and that's why we have a bond. That's why they're connected, because they're attracted because they made a different charge. It makes them connected. Okay, so what would we name this?
Cesium chloride.
Cesium chloride. Okay, so you guys try to do the next one. I'm going to pause this video too. Otherwise it's going to be really, really long.